Okay. Hello, everyone. It's time to get to work. Andrew and Kat here. Hello, Kat. I guess they've gotten over their fear of me talking to ghosts. So I left myself a note that I need to render every time an NMI would occur instead of every time an NMI does occur. I also seem to recall that I just get a big red box when I try to render, which is definitely wrong. So we got to figure out what's going on. That's where we are at. So first of all, I'm just going to render one scan line. And, hello, cat. Yes, okay, goodbye. Yeah, so if scan line is greater than 1, loop forever. Because that way we should be able to see what the problem is. Hopefully. Or not, because we only render on vBlank now. Or on NMI, rather. I gotta disable that correction. I guess that would be in here somewhere. Yeah. No, it's in cpu.execute. That's where I'm doing that now. Alright, so we're just going to go ahead and get rid of this bit, run for a single scan line, and then stop. Because we want to see how bad it is. Well, I guess that's more than one, because I'm foolish. Can't do math this early in the morning at noon. So everybody, welcome to the last day of this year challenge. You can do it. I believe in you. Thank you, Meeping Snesrams. Are you Cuttlefish? I know this, but I don't recall. Oh, jeez. Okay, so we draw red dots in this weird striated pattern over one scan line. So that's obviously wrong. Cuttlefish, hooray, I got it right. I saw that you followed me on Twitter earlier also. Thank you for that. Okay. The frame buffer. Well, this is almost certainly wrong, hey? Rendering pixel at whatever. And we're just gonna yoink, boink. Alright, so we start at the beginning. Pixel at 240, 480, 720. That doesn't seem right, does it? That explains the striations. I'm multiplying the wrong thing by 240. How far into the 2 weeks are we? Today's the last day, and I'm not where I really would prefer to be, but that's okay. I have all day today to work on this. Hopefully we can take it over the finish line. Once I get Donkey Kong working, the next major step is basically going to be getting the mapper for SMB3 working, at least hopefully, and then we should be good. Okay, so we rendered up to 135 linearly, and then we got all wonky somehow, which is odd. Dawn of the final day, yeah, absolutely. Thank you for coming by, Tobias VL. I don't think I've seen you before. I appreciate you. Stopping in to take a look. Okay. So we get up to 135, and then for some reason, cycle jumps to 255. Which, why does it do that, I wonder? Let's pull up our reference thing to see if there's anything suspicious at 135. There probably is. Cycle, cycle, cycle. Nope, nothing obvious. What the hell? Alright, when am I calling the drawy bits? Right here. Based on sprite state.cycle. I wonder if I have like a, oh, it doesn't matter thing going on here. Sprite q.push front. This would maybe be, well, no, it's after clear OAM. So sometime in test sprite or okay. Well, no, that still seems like it ought to be right. What about in here? Do we do something dumb here? Delayed until H blank. No, that looks like it should be correct. That never gets run. That seems right. That doesn't do anything. Hi, Diana. Cycle 0, cycle I. These all seem correct. Yeah, I was gonna say, aren't you supposed to be in class doing something? Alright. This should give me enough information to kind of figure out what's going on, at least. I should be able to see what thing is getting executed when the weird jump occurs. Oh, I bet I'm doing it in the wrong order. That would make sense to me. Right, so we have 135, but then we end up with cycle 255 because I'm pushing them in the wrong order because I need to loop backwards instead of forwards. Can you even do that? Whoop, hello. Jeez. Say hello first, cat. Especially when you're all wet. How did you get so wet? There, get off my keyboard. Sit on the cat chair. There you go. That cat is the fluffy one. He likes to jump into the shower after I'm done and then just like sit in the half-inch of water. I don't know why he does that. It's very weird. Okay, so this is at the end of read OAM bugged, I guess. Or maybe checked overflow. Okay, read away and book doesn't push anything. Right, so this bit probably is what's happening. And is going in the wrong direction because you have to push, whoops. So because my cue I'm pushing to the front of instead of to the back of, I'm doing this in the wrong order. Where these need to go the other direction. Okay. I guess that's not why. I basically just need to go through and, oh yeah, there it is, okay. Gotta be this. Rust ranges. Can you go backwards on a range? Nope. Can you call reverse on it, maybe? Probably. Let's try that. I forget how this works. Isn't there a way in an iterator to run it backwards? Rev. Thanks, friendo. I love it when I try to write the full word and then somebody was like, reverse is too long. Okay, that looks more like a real ass line. Although I guess I already kind of had that, didn't I? So we go up to, right, so we had rendering pixel at cycle 130, rendering pixel at 130. Okay, so this is much better. These are all in order, but it probably jumps back down sometime later on. So this should be good up to like 255, which should honestly be all we care about. Alright, so we render the pixel at 255, and then we don't render anymore. Excellent. Okay, that's much better. So now let's take out the loop and just kind of see how we do. It's extremely slow on account of all the logging and stuff, but that's okay. Should probably turn that off, huh? And it's extremely slow because we're drawing it every cycle. So I should probably turn that off. But at least it's drawing linearly, even if it is just a red circle thing. Or a red square, rather. Alright, let's fix the drawing way slow business. This continues to be wrong, but oh well. Not sure how I made it so much worse. Probably because I'm drawing, or I'm logging things all the time. Let's stop that, shall we? Holy crap, what are you doing? Jeez. Cats are weird. They're adorable and great, and everyone should have one. But they're so very strange. Catching one live. Hey, 8 little bits. Oh, by the way, thank you for your Twitch Prime subscription. That's impossible to happen, but whatever. I noticed it the other day. That's great. That's really appreciated. Okay, so this is what we end up with, which doesn't seem correct. You know what? Actually, I'm going to make sure. I'm just going to set this to 1 and break this again and just let it draw a couple scan lines and make sure that it's drawing the right pixels. It probably is. It looks like it's mostly doing the right thing now, but okay, it just kind of stops. Does it not make it to the end? No, it does. Drawing cycle 255. Is 495 correct? I don't even know. Doesn't seem correct. So that's strange. So I bet there is. I probably just need to. I need to reverse all of the iterations. So for I in. Right, anytime I do this, I need to write it backwards. That's fine. That's fine. Oh, well, this one shouldn't matter, but fix it anyway. Again, shouldn't matter. Again, shouldn't really matter. Also, this should go at the end, probably. Oh, no, that's correct. Okay. All right. Let's see what we get now. Go. I wish I could communicate to this thing that it should open this over here. Huh, so what's happening? GPU, drawing cycle 255 of scan line 1, rendering pixel at 495. So that's probably right then, I guess. If we have pixel 255 plus 240, except it shouldn't be times 240, should it? It should be times 255. That makes sense. Or 256 rather, because that's the horizontal, not the vertical that you want to multiply by. Probably should have made those constants a long time ago. Oh well. Hey, there we go. It's red all the way across. That's what we expected. All right. Whoop. All right, now let's just get rid of the loop and let it just kind of do its thing. Okay, so it looks like it is doing the correct thing and just drawing all the way across every line with exactly the same colors, which is obviously not ideal, but that's okay. How's the progress? I mean, something is happening. So in that sense, there's progress. It's drawing stuff. and it actually looks like it's drawing an entire screen, which is good. So we're rendering to this location, but then we got to double check that we have the right like indexes and junk, because that seems wrong since we're always getting red. Okay, so background index, whatever this is, palette index, whatever this is, pixel address, whatever this is, pixel color, whatever this is. All right, and you are gonna be PG index. Oops, PG index, palette index, pixel adder. This is like all my game jams on the last day. Yeah, for sure, right? I haven't done a game jam since college, but I remember it being very similar. I should probably render some small amount, and also I should log less stuff. So let's do that. Don't need every sprite UOP. Don't need, well, CPU cycle is probably a good idea. This appears to be correct, so we'll leave that out. That's useful just to know what scan line we're on. That never is going to get hit, but whatever. Oops. There's a bunch of stuff about this that I'm like thinking I should have taken more time with. Holy shit, cat. What is your deal? Is this what you do when I'm at work? Oh, and then I was going to turn it off at some point, right? So in BG no op, I was going to put the loop back in. If scan line greater than 4, loop. And so we should run the first 4 scan lines and then be done. And we should be able to see what's going on, basically. So here is the image. It's over here. And I want to look at background index 0, palette index 0. It's literally always that. So cool, 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 cool. All right. Right, so we just are always hitting palette index 0 of background index 0, which is why it doesn't do anything other than draw red. The red at least indicates that the name tables have been modified, because if it hadn't been, it would have been gray. So something is wrong probably with the pattern latches or something. Right shifted by cycle mod 8 and 1. Alright, so let's just pattern latch low is going to be pattern latch high is going to be attribute latch low is going to be attribute latch high is going to be and then pp.bg pattern latches, and let's make an entry. 0, 1, attribute, and then swoosh. Okay, so these are all 0 all the time. When am I supposed to be setting them, and am I just not doing that? BG pattern latches are getting set in inquiries, which I guess for the first frame could just be wrong, or for the first scan line rather, could just be wrong, but BG low byte, BG high byte. I might know why this doesn't work. Turns out if you don't shift your shift registers, they'll always return the same data. I'm never writing back to them. view.bg pattern latches 0 equals 1, 1, then s pattern attribute g, and these become 1. I bet that helps. Maybe not. Okay, so going back to the top here, what do we get? Do I need the and 1 on the shift or just shift it? Nope, good point. Yep. Also, it doesn't need to be parameterized by the cycle at all. You know what? Actually, this is not how this works at all, come to think of it. It's probably in inc horizon that I should be doing that. Inc horizontal. Because what should probably be happening is that we should be shifting the top 8 bits down when we load them again. And since we don't do that, this is obviously not going to work. So, pp.bg pattern latches 0 equals pp.bg pattern latches 0, right shift 8. Do it again with the 1. You aren't actually supposed to modify it there, which is why I wasn't modifying it there, because I'm a smart boy who always does the right things. But it does need to get shuffled down here. Whoops, attempt to shift right with overflow. What? Oh, the pattern latches. Okay, that's fair. Or the attribute latches. I don't think you actually change in this way. You actually do get shifted out, probably. But we'll leave that alone for a moment. Because of how this works, we won't actually see any changes until the second scan line, and then we're still not seeing any changes, which is not ideal. Let me just pull up the reference. Excuse me, I'm going to mute my mic for a second so I don't subject you all to blowing my nose. And we're back. Okay. The image that I'm thinking of is in the file called PPU rendering. There we go, right here. So, every 8 cycles or shifts, new data is loaded into these registers. So that's probably wrong. I'm not totally sure what I thought was happening because it doesn't seem to match this at all. Right, so oh no, I guess you do hit ink horizon every 8 cycles, so that is correct. All right. Every cycle, a bit is fetched from the 4 background shift registers to create a pixel on the screen. Which bit is set depends on the spline X scroll, which I'm not using. Afterwards, the shift registers are shifted once to the data for the next pixel. So they do get shifted. Every 8 cycles shifts, new data is loaded into these registers. Every cycle, the 8x position counters for the sprites. Okay, no one cares about sprites yet. So, 2 16-bit shift registers, pattern table for the 2 tiles. Every 8 cycles, the data for the next tile is loaded into the upper 8 bits of this shift register, which we are doing. Meanwhile, the pixel to render is fetched from one of the lower 8 bits, which we are doing, but we're not shifting. Are we supposed to be? I'm sort of confused. These contain the palette attributes for the lower 8 pixels of the 16-bit shift register. These registers are fed by a latch, which contains the palette attribute for the next tile. Every 8 cycles, the latch is loaded with the palette attribute for the next tile. So we're doing that right. So ink horizontal, low 0, high 0. What are we looking at? PPU background low byte, PPU background high byte. So if those are ever not non-zero, or not ever non-zero, then this isn't actually the problem. Although it certainly was a problem that I was not shifting the things at all. Assert PPU.bg low byte is equal to 0, 0, 0. And PPU.bg high byte 0, 0, 0. That'll blow up if it's ever non-zero, and if it's not, then something's wrong. Okay, so we're just always fetching 0, so that's not right. When is that supposed to get set? BG low byte gets set right here. Maybe multiply by 8 here? Not sure. Gee, thanks, past me. Accessing. Address. BG. And we'll see if that ever changes. And I'm also going to change the loop to be fewer cycles. So it only really needs to be 2. Hello everyone, thank you for stopping by. This is the last day of my 2-week NES Emulator Challenge, and I'm somewhat behind where I would like to be, but that's okay. We're gonna work hard today and see what we can get to. Address 0 for background low, address 8 for background high. Is that what that's supposed to be? Look at the name tables, or the memory map, rather. Pattern table, name table, palettes. Could have swore I was following you already. Odd. Well, I appreciate you following me now. That's very nice of you. So it looks like we're just always getting the same addresses, which doesn't seem totally correct. Let me check another thing real quick, actually, based on the registers. Base name table address, sprite pattern table address, background pattern table address. Okay, so the background pattern table is setting us to offset 0. That makes sense. Okay. So this is based on the name table byte, which is set right here. Fetching NT byte at address adder. Because that should be different. The address should change, and if the address does change but the name table byte doesn't change, then we need to see if we're ever writing to it. And if we are, whether we screwed it up. Fetching name table byte at address 2000F. Okay, so those are incrementing, which is good. That's what one expects. And so wait a minute. That doesn't seem right. If the name table is a kilobyte, .30 rows of 32 tiles each. The rest is used by each name table's attribute table. Each tile is 8 by 8 pixels. So I probably need to be offsetting this by the scan line as well, huh? Since each tile is 8 pixels and has 30 rows of 32 tiles each, it's 960 bytes. So what I need to be doing there is I need to be offsetting this by, I guess, scanline mod 8 so that I get the right thing. I feel like Lila had something good about this. Each byte represents a tile number. Which of the name tables it's part of, blah, blah, blah. Well, that's not super helpful, is it? Alright. Well, it makes sense to me that you would want to have tile plus scan line divided by 8, right? Scan line's already a U16. Maybe it's not. Can't hurt. Anyway. But it shouldn't matter because we're only drawing the first set of tiles. Right, but the tile, so hang on. So the sort of struggling here. Hello, cat. I need to take a minute to like understand a little bit better. So what is happening basically is that you fetch the name table byte, and the name table byte controls this is sprites rendering. None of this is useful. So, I guess what's happening here is you fetch a name table byte, and the name table byte controls 8 bits, right? You also fetch the attribute table byte. NES is Nintendo Entertainment System. It's the original NES, or the original Nintendo console. I lost my train of thought. So you fetch the name table byte, and that controls one 8x8 pixel character cell. I don't understand how that works. Because we're only going to draw 8 pixels before the next name table fetch. What language am I using and what OS? Also, hi. Hi, Hayden. Thank you for stopping by. I appreciate that. I am using Rust, and this is in Windows, but it would run just as well in Linux, I think. Just using OpenGL. So fetch a name table entry, fetch the corresponding attribute table entry, and increment the current VRAM address within the same row. That's interesting. I'm not sure what that's supposed to mean. Fetch the low order byte of an 8x1 pixel sliver of pattern table. Fetch the high order byte of an address 8 bytes higher. Turn the attribute data in the pattern. Yep, that's not going to get posted. Rust is a balloon. Okay, so increment the current VRAM address. I'm live already. Yeah, hi Lila. Sorry, I thought that was I don't know, implied, I guess. Can you help me understand what the hell? So basically, what's happening currently is that I am capable of drawing a red square, pixel by pixel. It no longer stripes across the whole screen. I fixed that. It no longer stops before the last, like, 12 pixels. Alright, Hayden, that's enough from you, I think. How do I time you out? I don't know how Twitch works. Oh, there it is. Alright, there we go. Right, so basically what's happening, I can draw a red square, I can draw it correctly across the screen, scan line by scan line, but the problem is that it's always red. So when I try and print out why it's always red, basically what I'm getting is that, first of all, I'm pretty sure I'm fetching name table bytes wrong because I don't get far enough into the name table for it to make any sense. And then second of all, I just always end up accessing address 0 and address 8 for the 2 pixel slivers that I fetch, and it just is not helpful at all. So I'm trying to figure out exactly what the name table stuff does. So you fetch a name table entry, I'm guessing, even though each byte in the name table controls one 8x8 pixel character cell, I'm guessing that you have to fetch it 8 times because you can only get an 8x1 sliver of pattern table, right? So the first 8 scan lines are going to fetch the same name table bytes across every time. Is that right? Yes, okay. And then when you fetch the attribute table, given the palette numbers, oh, I haven't looked at this even hardly at all. So this is almost certainly wrong. What a weird snake pattern that is. Attribute table is at the end of each name table. But surely I shouldn't always be fetching the same, or I shouldn't always be getting address 0 for the name table. Right? So then once I fetch the name table, then what I do is I offset into the pattern table based on the name table byte. Is that right? Yeah, okay. But the name table byte that I'm fetching is always 0, as far as I can tell. And I don't understand how this allows, like, the tile to be different through the... Right, like this would only draw all 8x8 squares as exactly the same pixel. So I must be doing something wrong somewhere. It could be the attribute table stuff, which would be completely reasonable. Hey Andrew, you're looking like a snack today. Thanks, Rock Polish. I'm feeling like I could eat a snack today. Can you dump out your NTs somehow so we can rule out that the NTs are populated wrongly? I'm pretty sure they're populated right, but I guess I could do that. Where do they end up? In RAM. I guess they'll just end up at whatever my get NT base is returning. I'm pretty sure they're at least like reasonably populated, but 2,000 to 2,400 would suffice. When? On like the first NMI or something? And how should I dump them? I mean, I guess I could dump them as like shades of gray. Not sure when the first NMI as far as after the whole PP battery, PP data stuff is done. I don't know when that is. I guess we can just like run for some amount of time and then call it if we want to. Whoa. Oh. Okay. Huh. Alright. It looks like we did eventually fetch something that was not 0, so that's good. Hello, cat. It's extremely slow because of all the printing. That's a black square. That's a red square. He takes a whiskey drink. Okay, so it looks like we are getting something other than 0 now, right? PLL 7878, PLH 0, ALL 24, ALH 24. So that's progress, I guess. It looks like it is at least populated. So, Lila, I don't think it's that the name tables are populated wrongly, because, like, that's not my problem. Like, they may also be populated wrongly, but I'm not even to that point, I don't think. Because the way that I'm currently doing this, right, if I do fetch NT, there's no way for a tile to have different pixels in it. Like, they could have different pixels as, like, the 8x1 slice, but all the rows would have to be the same. And I'm pretty sure that's not true, right? What do I mean? So here's what I mean, okay? So I fetch the name table byte based on the tile and the scan line. I'm pretty sure this is right. I fetch the attribute byte based on the name table byte. Pretty sure that's right. And then I fetch the 8-pixel slice based on the name table byte. But the name table byte is always the same for the whole tile. And so I always fetch the same 8-pixel slice. But that doesn't make sense, because it means that it would have to have the same slice. The scan line indexing gets a different byte, no? That's why you need to offset your tile that is read in. What? I mean, I am. So I'm offsetting it by scan line, but that's scan line divided by 8 because it's a tile index, right? You're supposed to have the same name table for the whole tile. It says that all over it. So am I supposed to add scan line, I don't know, mod 8 here? Is that what you're saying, Lila? Or something like that, scanline times 8 maybe. Some function of scanline is supposed to be offset here in the fetch background and fetch background. Okay, so that would make sense to me. Not sure where in your code. I also have to do maybe multiply by 8 here, not sure. So basically what you're saying is that as the scan lines increase, you're supposed to offset each entry in the pattern table, so each tile consists of 8 by 8 pixels. Try displaying our pattern tables. Check pattern tables, it shows how the tile is drawn. Yeah, but it doesn't. Like, I know what you're saying, but it is not helping me, I guess. Because, like, there's not even a reference to a scan line in here, as far as I can tell, unless that's R, but can't be R because that's the wrong thing, and it can't be column because that's not long enough. So, like, what the hell is the scan line? You will read the same name table byte 8 times at x equals 0. Right. When you read the tile from that name table byte, you will need to know the current scan line. So you know which line of the tile you have to read in. Okay, so that's what I'm doing here. Now, by the way, it really, like, I don't know. When you say read the tile from that name table byte, I am, like, rebelling against that because that's not what happens, right? It's based on the name table byte. It's not from the name table byte, but I know what you meant. Okay, still drawing an all red square. So that didn't, like, magically fix everything, but it should at least have helped. So take a look at this, maybe from the beginning. Okay, so name table byte at address 2000. Right, I'm doing that. Accessing address 0 for BG low, accessing address 1 for BG high, right? Name table byte at address 2001 is almost certainly wrong. Oh no, that is right because we're going across the row. So we should get whatever for BG1 and 0. Okay, but then when we get to scan line 1, which should be in here somewhere. I'm printing way too much stuff. I gotta remove some of the more useless junk. Alright, so here's scan line 1. And when we go in, yes, so we access address 1 and 9 for background low and high. So that is better. Each line of the tile consists out of 2 bytes and they are offset by 8. So byte 0 and byte 8 form row 1. Byte 0 values at 1, byte 8 values at 2. Right, so I am doing that because I have this fetch background low, which fetches to the low byte, and then I have fetch background high, which adds 8, fetches to the high byte, and then when we use that stuff to draw, which is in here somewhere, right, we set these pattern latches based on the low byte and the high byte separately, and then when we do the drawy stuff, we shuffle them out separately, low and high, and then we combine them together by left shifting high once, which is the same as valued at 2. So that's better. I'm going to delete a bunch of prints because they're not actually helpful. I like this one. That's helpful. The problem is that a lot of this is helpful at this point, but this seems to be correct now, so that's good. Uh, Alright, let's see if this is better. Oh, I'm still printing executing PPU cycle, which is probably extremely slow. See what we get. Oh, I forgot to not do this, but anyway. We still only get a red box. But it does look like we've progressed because we do end up with different values, at least, in our pattern latches and whatnot. So that's good. I think I need some more coffee, honestly. Okay, so things are changing, right? And we have this, and then we have this. Am I printing? Yeah, I'm printing this junk, which is not actually what I want to print right now. Let's print this instead, so we can see the background index move. Okay, so we can see the background index is moving between 0 and 2. The palette index is moving between 0 and 3. I'm pretty sure I'm doing the palette index wrong. Let's get rid of the fetching name table byte. Is that what we want? No, probably not. We want these. Can you output VRAM at 2350 and at 2222? Maybe? I'm not sure what you mean by VRAM. Which address bus are you talking about? Are you talking about the PPU address bus? That's what you mean by VRAM? Is sure? PPU, yes. 2350 and at 2222. Just the 1 byte? I mean, yeah, sure. Sure. 2350. Sure. 2222. And that's going to be mapper dot borrow get byte PPU 2350. Do 2222. Randomly selected by fair dice roll. All right. Looks like zeros. Oh, there's 24. Now it's 24 in both places. And it doesn't seem to have resolved. So, yeah, so 24 is right, but 22 is wrong. Based on what you're saying. Is there anything other than 24? I mean, it could be. I don't. I don't know. This seems less than likely to me, but okay, let's just do this. For I in 2000 2400. I just want to verify that the name table is correct so you don't work on outputting something that isn't there. Oh, there's a comma here. Yeah, I mean, I understand that. I'll be very surprised if the name table turns out to be so grossly incorrect that it's all the same value all the time, but this is going to take a while to get to something that's not zero. Maybe I should not print all the zeros if it's all zero. But I don't really have like a thing to do that with. All right, here's what we're gonna do. We're gonna kick this off, and I'm gonna go get some coffee, and I'll be right back in like 3 minutes or so, and then we'll see what we got as our result. Sound good? I'll be right back. Just gonna go top off the tank. Okay, I'm back. Turns out my coffee pot is faster than my NES emulator. So, what we're going to do instead is if self.cycle count is greater than, let's say 8 million. That seems like a good number. No, it doesn't. Seems like too small of a number. Let's say 128 million. Then we'll print it out. Oh, it needs a. That's what's up. And then we'll panic. We're trying to verify that the name tables are correct, or at least non-zero at some point, which they are, because we eventually fetched something that was not zero, but Lila wants to make sure that my name tables are correct, which I guess is fair. I'm suspicious of that as an explanation, but hello, cat. Please stop standing on my mouse. This is the current state of affairs of my Nintendo emulator. There is a red square. The color seems to be approximately right. It's just too much. Boy, it sure takes a long time to get to 128 million when you're printing all this junk. I should probably stop printing so much of this junk. Or I should debug it, or I should log it to a file. $500K should be enough. You think so? That's less than a frame. No, it's not. I just counted bad. Okay, we can do 500K, since this is apparently taking a very long time. I'm sort of surprised. It doesn't seem like it should take this long. Oh, hey, there we go. Look at all these 24s. When you're right, you're right. Oh, no, there are some spots that are 0. So it's either 24 or 0. Wow, that was a lot faster. I mean, it looks like 24 and 0 are the only things that get written to PPU data. So I don't know what to tell you. All right, let's see here. So I don't know how this could be wrong unless I have the wrong address for PPU data, I guess. Or I'm not, well, no, even that wouldn't. Yeah, the only thing that could be that way is if it was. Whack. Hello, cat. Do I buffer the PPU data? No. Probably not. What do you mean exactly? I did read this thing about when you read from PPU data, it does something weird where it like buffers and reads the contents of an internal buffer. I did not read anything about that on write. Oh, cat, stop doing the thing. Okay. Yeah, I don't read anything about that for writing, though. I'm not even sure if PPU data is ever being read from. We can check that. I guess it must be because I otherwise wouldn't have implemented it, but maybe that's not true. I don't know. Let's find out. Right, so we dump all of the RAM. We write a bunch of junk to PPU data. Doesn't look like we ever try to read from it. At least not immutably. And I doubt that it's read from mutably, because that would only actually be for... Well, I mean, that could be a problem if this is done. I don't remember where this is staying. I don't remember why I wrote this function, honestly. So, nope, no mutable references to PPU data. I don't see how I could be screwing this up unless I have some sort of horrible CPU bug or something. So what happens in setReg after we do this? So we go self mapper borrow mute set by PPU. So what does that do? Oh. Did I screw this up? It's possible I screwed this up. Let me see the memory map again. Right here. So, if we're writing to, so I'm asserting that it's between 2000 and 4000, which makes sense. If it is between 3F and the end, we get the address based on this, and we write to palette RAM, which does seem correct. Otherwise, if we're in this range, we AND it by 3FF, and we write to chur RAM at that address. We are not changing the other two name tables. Do we ever try to write to them? Because it won't work if we do. But I don't think we do, right? These are all less than 4000 or 2400. Yep. Okay, so that seems right to me. Unless I really effed it up somehow. I'm almost certainly reading from the wrong attribute table. I was noting this before. Because I have it hard-coded as 23C0, which is correct for Donkey Kong, but not generally correct, I assume. but that's fine because this is Donkey Kong. So, hello, NIST Online. Thank you for stopping by. You've stumbled on the last day of my 2-week NES emulator challenge. Storing by PPU data goes through STA. (8D) opcode. Okay, yeah, that makes sense. Maybe CPU bug again, wrong A. Could be, I mean, at a certain point we've got to stop having these bugs, but alright, so 8D, STA absolute is what you're saying. Fetch, fetch, write. Fetch and decode. So writing to address value CPU.get address bus val. Anytime we write to memory, we will print out. I probably should be making sure that the address is 2007 because otherwise CPU.get ab 0x2007. Go. I mean, it's either 0 or 24. But really, anything that modifies A up to this point would have to be what was wrong. So did you find out when it writes non-A values? Also, that's interesting because it writes to 24C0 at some point, which is wrapped around. That's part of the second name table, but 23C0 is kind of what I would expect it to be because that would be the pattern table. So I wonder if I have my latch wrong for that, or the attribute table rather. It's in a cycle, so the PC doesn't help much. Sure. So that is interesting, and I wonder if I have this bit wrong. The line prior to this does a load A 44Y. So that's opcode B9, load A absolute Y or indirect Y. B1. Right, indirect Y, okay? There's going to be a lot of those. This is the problem with your CPU only having like half a dozen opcodes. Whee! At some point, it will all click. Yeah, I mean, there's gonna be something like obviously dumb. Well, that's interesting, isn't it? Okay, so I definitely have a problem here because oh wait, do you have a brilliant idea? I do increment PPU address, right? Yeah. You mean when PPU data is written to? Yeah. So this is obviously wrong. I'm definitely setting the attribute tables wrong because I need to set this latch cleared signal once the second thing is written. Basically every, it's not clear in the documentation, but it makes total sense that you would want it to kind of wrap around like that. Every second write goes to the high byte. So that should help because we'll at least have the attribute table and the pattern table separate. Right, because we've got all this junk and then we were loading the address wrong. So that's better. 23 skidoo. It looks like we literally just fill all of it with 24 and then overwrite the attribute table with 0, which is an interesting way to do it, but sure, whatever. And then the other thing is, so you said that this is an indirect Y. So it's more likely that the problem is in fetch indirect or is a problem with Y. Fetch indirect defective address CPU.getAB. And then we're going to delete some of the other prints because they're not useful. Like this one and this one. Oh, well, that one's fine, I guess, because it's only when we write to the correct address. Okay. Go. Wish I knew it was taking so long there. All right, so choo 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 doo 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 doo. So much of this junk. Interesting. It doesn't look like that load A is getting executed. can I check later? You mean like just let it run longer? Loads 24 to all cells first. Yeah, okay. Still all 24. Still the last thing that we did was flood it with 24s and zeros. $128 million. Ready, set, go. Do 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 do. Do 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 do. Do 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 do. Whoa. There we go. After 128 million cycles, it's still all 24s. It seems like it's maybe waiting on something that doesn't happen. It's weird that we never call a load indirect Y after we fill the name tables. Oh, Could it be waiting on a sprite 0 hit? Because I don't think I'm doing that right now. I don't think DK needs sprite 0. Yeah, see, I didn't think that it did. But SMB does. I mean, it should be relatively easy to do. Animize are still working. I mean, as far as I can tell, they are. I wouldn't be drawing anything if they weren't. So at least 2 are firing. Wait a minute. What? It actually looks like they aren't. What? What? Huh? So I just like turned off NMIs at some point? How? I don't suppose I had them last time I committed to Git. Probably not. Nope. This is what I get for basically never committing. Yeah. Yeah, no. Awesome. Cool. Great. Wonderful. How? How? Ugh. Okay. Well, I guess let's re-implement NMIs. I'm so baffled by this. I don't understand how this can be true. All right. Well, whatever. I guess. If NMI and not NMI last, do the NMI thing, which is basically what you push. Oh wait, hang on. Maybe I just moved it. Actually, yeah, I did. I just moved it. I remember now. It's because we were firing it every time. Okay. Much better. All right. That makes way more sense. If I had just turned off NMIs and forgotten about it, that would have been something else. Hey, look, they're basically not firing, though, so that's interesting. No NMI equals NT full of 24. Yeah, I mean, that makes sense. So I think what I did... So I'm only checking the difference on fetch and decode, but I'm updating it every time. So I think what I want to do is only update NMI last in here. Nope. Okay. Let's see if we're ever trying to fire an NMI. Yes, we are. So there's something wrong with how we are dealing with them. I'm not sure what exactly I think I'm doing here at this point. Vis-a-vis NMIs. I should probably just simplify it instead of trying to use minimum number of state bits. So the PPU says, hey, I set an NMI. And it probably will do that continuously, right? Yes. Yes, it will. Which is fine. That's what we expect. And then we set the CPU's, hey, an NMI happened flag. And then, you know what, we probably need to update this regardless, right? That's probably not going to help, but and then, I mean, we're probably never going to render also, which is super cool. Yeah. Okay. Here's what we're going to do. We're going to leave NMI and NMI last. We're going to get rid of this bit. NMI occurred is false, right? And then if we're in here, we're going to do NMI occurred equals true. And then we're going to say while not NMI occurred. And then we're going to add in an NMI occurred flag to the CPU struct. Which starts as false. It's not self, it's CPU. And then, of course, this bit is also wrong. No field NMI occurred because I misspelled it. There's 2 R's. There we go. That's better. Look at my NMIs. Of course, we are still having this problem where we just occur NMIs over and over and over and over again, which is great. Can we have one that was like, hey, you're executing an RTI? I guess not. I guess we got rid of that. So this suggests that we are executing an NMI every cycle. Because this will print every cycle, and if I run it, I bet I get an NMI every cycle. Yep. So how does that happen exactly? Is all the NMI code just gone? No, it's not. It's right here. I moved it into the fetch and decode stuff because we were firing it in the middle of UOPS, if you recall. Oh, hey, guess what? This isn't actually unconditional, is it? Goofy. All right, this should probably help. All right, so some stuff is happening. There we go, that's better. Hey! Look at me, I got Donkey Kong. Can't use hell, it's extremely recognizable and good and right. Hooray for progress! That's awesome. Oh, and then we exploded. So here's my name tables now. They're different. They're not all Fs or 24s. They're only mostly 24s. Dope as hell. Alright. That's progress for sure. What were those two that you wanted me to check, Lila? 2200 and 2350? $2,200 is 24, which we said was correct. And then 2350, I think you said was 12. Nope, 38. And 2222 is 24. So you said 2350 should be 12. It's 38, which doesn't seem 100% accurate. Okay, I'm going to take out this fetch indirect thing, because I don't think that's actually the problem. And it's masking a bunch of other junk that's useful. Well, close-ish. Yes, progress, definitely. Things change. Time passes. People move. I think that's the Ocarina of Time quote. It's been a long time since I played that game, because frankly I don't like it that much. Blorp, blorp, blorp. It looks like I'm getting various rights to the name table. So it could just be that we looked at a different time. Or it could be that I'm not supposed to be getting rights to the name table. Where to go from here? Well, I'm now much more... Yeah, I mean, this makes total sense. It's just kind of bit bopping around now. I could break on the 2350, right? Yeah, I could do that. All right, why not? If self dot get latch equals 2250 or 2350 rather, print line writing to address. Oh well, I mean, I guess I'll just move this under here. All right, go. Oh, I forgot I still have this turned on, which is not useful again. It was 12? You mean like the first write to it or something? Alright, let's blow up on it, shall we? And that way we can see more clearly what's going on. Oh, I should probably turn these off because they're not all that helpful. Well, I mean, obviously it was 24 first. So let's say if value is not equal to 24, then we'll panic. Yeah, we do write 12 to it first. So there you go. It's all good. It just changes over time. so I don't need to worry about this anymore. It looks like my name tables are right, but I'm still drawing kind of the wrong thing. Let's get rid of this thing here, huh? Just for now, at least. I don't think it changes over time. The DK menu is static. Well, it's being changed over time, so I don't know what to tell you. Oh yeah, I forgot. Explicit panic. And value is not equal to 12. We'll see what the first non-12 thing written to it is. Non-12 and non-24. Interesting that that took a really long time to happen. Didn't I? Hang on. I wonder if it's part of the mirroring. What do you mean? I thought we were only using one name table. Whoop, there's the explosion. NT-mirroring, yeah, but still the bottom left name table is mirrored in Donkey Kong, maybe NROM in general. I don't think that's relevant. But, right, so last 16 kilobytes or mirror of 8, whatever. We aren't writing to addresses. This is CPU stuff, I guess, actually. So this is not right. Name table mirroring, solder pad, select horizontal or vertical. Name table mirroring, it shows what is shown past the right and bottom edges of the current name table. When mirroring is enabled for particular access, coordinates simply wrap around. Background mirrored in this way is repeated, not flipped. When mirroring is disabled, the second name table is used. So this would only show up if we were reading or writing past address 2400, right? So we can always just assert that that doesn't happen. Also, I'm mirroring all of those down to name table 1 anyway, but address is less than 2400. Let's see if we hit that assert anywhere. Also, I'll turn off this. Well, I guess it doesn't matter. It would happen before this point. Are you sure? This is probably supposed to be greater than or equal to, huh? Okay, better. And you're sure that the name tables are static, because this is pretty obviously writing to the name tables. in a bunch of places. The menu doesn't change at all unless you select something the sprite moves. But doesn't it have like a demo thing? Only after a while. Well, this has been a little while, right? So maybe that's why? Because the demo has started? Am I emulating really fast right now? I'm not slowing anything down. I'm just letting it run as fast as it'll go. So I'm thinking this is fine. I'm thinking I have a rendering problem personally, but current PPU cycle self dot cycle count 38. Okay, so that's on cycle 15 million of the PPU, which would come out to be, I don't know, not that long, I guess, like 5 seconds. If we were running at speed. Anyway, I obviously have a rendering problem, so I'm going to focus on that, I think. Because if I turn that off and let it run for a little while, these are obviously wrong. I get a red line. Some other stuff happens, I don't know. Alright, so let's look at rendering. It looks like basically I'm rendering the same tile over and over again, and that the tile is broken. So, let's see if we can figure out what's going on there. Whoops. Oh, I guess I'll turn this panic back on because that's when it starts changing. Here we get a little bit more texture, which is good. And then eventually we explode. So I'll just wait for it to explode. I'm hungry. I had lunch, but I'm hungry already. Yeah, I don't really have any snacks, but I'm sure I could find some if I looked. Logging takes a while. Yeah, no kidding. Just gonna log it to a file. It'll be better. Not that much better, but better. So what's going on here exactly? This seems right, more or less. Are those ever different? I guess they are. This is 18C. 1818. Yeah, I'm definitely doing something wrong. Excuse me. Fetch AT, I think I'm doing wrong. Bless you. Thank you. Maybe not. I feel like I remember reading a thing about the attribute tables. What am I thinking of here? There's a thing which is like, this is what always happens. So, okay, yes. Fetch a name table entry. Fetch the corresponding attribute table entry. And increment the current VRAM address within the same row. I don't know what that means. Something wrong with the attribute tables, I'm pretty sure. Each attribute table is arranged as an 8x8 byte array. Each byte controls the palette of a 32x32 pixel or 4x4 tile, part of the name table, and is divided into 4 2-bit areas. Each area covers 16x16 pixels or 2x2 tiles, the size of a question mark block in Super Mario Bros. Given palette numbers top left, top right, bottom right, each in the range 0 to 3, the value of the byte is, or equivalently. Most games use 16x16 or 32x32 pixel meta tiles in order to align the map with the attribute areas. The byte has color set 2 at bottom right, 2 at bottom left, 1 at top right, and 3 at top left. Thus, its attribute is calculated as follows. So I think my my fetching of attributes is correct. 38 was the value written to 2350. Yes. I'm going to mute myself again to blow my nose. So I think I'm using the attributes wrong. Where's the... So much sneezing. What am I looking for here? Here we go, PP rendering. So I think I'm doing the attribute bytes wrong because afterwards the shift registers are shifted once to the data to the next pixel. 2-bit palette attribute for next tile. 1-bit latch. Yeah, so I'm doing this wrong for sure. The attribute thing is absolutely incorrect. I don't really understand. Fed by a latch which contains the palette attribute for the next tile. This is like a 1-bit latch. Or 2 1-bit latches. Is what's going on here. So I gotta change how this works. I gotta extract the appropriate attribute table value out of this guy, out of the byte that I'm fetching. Right? And the way that we do that, I guess, each 16 by 16 area has one of 4 color sets assigned to it, and 1 byte controls 4 color areas. So the way that you figure out the bits to use are top left, top right, bottom left, bottom right. D1 and D0, D2 and D3, D4 and D5, D6 and D7. Okay, so that all makes sense. We got to extract it based on the tile that we're rendering. So if the tile that we're rendering is, well, the tile in the scan line, I guess. So if the scan line is between, scan line mod 16 is between 0 and 7, then we're looking at this half, right? If scanline mod 16 is less than 8, bottom half of byte. And then if tile mod 2, I guess, is equal to 0, low bits, else high bits. So what we're going to do is let big shift equal if scanline mod 16 is less than 8, 0, else 4. Let small shift equal if tile mod 2 is equal to 0, 0, else 2. And then we're going to do right shift, big shift, right shift, small shift, and 0x0, 3, because it's 2 bits. And then in here, the attribute latch, we're just assigning them here, which is fine, I guess. Well, not really. We'll just make only one. Or we'll make it latch as, but we'll just assign it like that. And then this junk is going to go away. Palette index is just going to be PPU dot BG attribute latches, right? That's what that was, right? Yeah. And then we're going to need to change struct PPU because this is just going to be a U8. And then when we construct it, gonna need to fix that too. It's just be A0 instead of 2 zeros. And then hopefully this will build and run, but probably not. 96 is this bit. Oh yeah, we just logged this. Go. Interesting. How did I break stuff? I barely changed anything. Gosh darn it. Uh... Scan line, tile, big shift, small shift, PPU dot attribute latch. What's this beautiful setup? So this is Rust implementation of a Nintendo emulator. I don't know why I said it like that. NES emulator, original Nintendo emulator. I'm trying to implement it in less than 2 weeks to get Super Mario Bros. 3 running based on a challenge from a rando on the internet. Hi, Sai. And we're just trying to figure out why it's not even sort of working. So that's how my day's going. Previously, it drew a bunch of weird corrupted tiles. Now, it just draws a red line. Although it's very, very slow when I log all this junk. I was wondering about your shell. Is that Sigmund with Zeesh? Yes. Yes, it is. Because I find that whatchamacallit, Mingua does not work well for me, and so don't use it. So I use, what am I looking at here? I use Zeesh instead. That works well for me. I'm not saying anything sensible. Sorry, I'm thinking. Yes, it's Sigmund with Zeesh. Okay, good. So on scan line 8, big shift becomes 4, which is what we expected. Alright, that seems correct. And then obviously the text editor is Vim. That should be pretty discernible. This is interesting because it seems to think that it's getting different colors, but in fact it's not. Or it just hasn't rendered yet, maybe? I don't know. It's hard to tell. I'm obviously logging way too much stuff. Let's turn off some of that logging. See what we get. Am I still logging NMIs? I should be logging NMIs. Yep, okay, good. I'm feeling pretty lost at this point. What did I have before? I was doing something completely incorrect. Let's see if we ever have a non-zero palette index. We do. Okay. See if our palette index ever becomes invalid. Shouldn't. Nope. So what happened? It seems like we should be getting more colors. Although, wait a minute, did we stop getting NMIs? Where are the NMIs? I mean, I guess I'm just printing too much stuff. But it does look like we're getting more. We should be getting multiple colors and not just black with a one red stripe. So I wonder why I'm not seeing that anymore. Very confused. We do run a bunch of NMIs. We do render to a bunch of different things, it looks like, but I mean, this looks like it's basically doing the right thing. Interesting that we hit 2 NMIs between renderings, and that we then start rendering at 256. Neither of those seem right. Oh, that's just where it died. Okay, that's fine. I should really be logging this to a file. Let's do that. Three, four, five. Oops. Donkey.log. Okay, so the pixels appear to go in order. Up to the end of the first frame or so. There's no NMI after the first frame, so that's interesting. And then when we loop back around, we get 25. So that's also, or 256, that's also interesting. We get an NMI, we only get 1. That's good, but we still jump back to 256, which is strange. Then we get 2 NMIs in between each scan line after that, which is not impossible because it can do the thing where it like modifies the whatchamacallit, the PPU's control register to get to NMIs. I don't know if it's doing that on purpose. It doesn't really seem overly sensible, but this is obviously wrong. I don't know why that would be happening. So okay. So again, we start with scanline 0, but then for some reason the first draw that is called is on scanline 1 after the NMI. Oh, hello, Infinite NES Lives and Rating Party. Thank you for stopping by. This is very kind of you. You're encountering day 14 out of 14 of my 2-week NES Emulator Challenge, and nothing works. Well, that's not true. We've made some progress, but I'm struggling with rendering at the moment. We'll see what all we can figure out. So why am I not getting a scanline 0 happening here? This is probably supposed to be mod 261. Right? And then what's the last thing that happens? We just finished day 0 of trying to connect the NES to the internet with a new cartridge mapper. Ooh, that's exciting. Did you do the hardware design for that? Or How did you come to that? Like, what's the overall setup? I guess is what I'm asking. Yeah, I'm working on the hardware portion. That's super cool. I haven't done hardware design in quite a while, so sounds like fun to me. Scanline +1 mod, whatever. Where was I? Yeah. Are you an electrical engineer, or is this just a hobbyist thing? Not just a hobbyist thing. Is this a hobbyist thing? We'll be using the ESP8266 since it's dirt cheap and can be included in a release game. Makes sense to me. Yeah, that's probably where I would have started, either that or the 32, the ESP32. Yeah, I'm an electrical engineer to do this NES hardware dev full time. Wow, that's cool. If you had asked me, I would not have suspected that that was something that could be done full time. Do you just make money off of selling it, or do you have some sort of sponsorship? What is happening? Didn't change anything. Maybe it wants to be mod 262? Because 261 is a thing. Yeah, that's probably it. Yeah, we sell new cartridge hardware online. My brother does all the manufacturing at home full time as well. Wow, that's really awesome. How does that work? Is he... Let's see, what would you need? You need a case, which you could 3D print. That would be my first guess at how that would be done at home. You would need the circuit boards, which you could do at home, like etching in a bathtub or whatever, or if you bought one of those like PCB mills, or you could send them out, obviously. Assembly, easy enough to do at home. I do that all the time. What else would you need for that? I mean, I guess that's pretty much it, depending on whether you gold plate the fingers and various things like that. But yeah. So is that basically how it works? 3D print the cases and then contract out the circuit boards? Ooh, an NES injection mold. Awesome. That's obviously the way to go if you're making sufficient quantity to justify it. Which it sounds like I guess you are. So congratulations. Okay, that looks better. Not terribly clear on why it started happening after the last change I made, but alright. So let's take some of these prints out so that we're not trying to log every single pixel, because it turns out that's very slow. Who knew? I knew. Everybody knew. Well, that's great, Infinite Nest Lives. That's really cool. Do you do the dev on Twitch for the most part, or is this project special in some way? Okay, so now all I'm drawing is black. Awesome. Thanks, yeah, I have a lot of fun with it. Yeah, I bet. Sounds great. Wish I could do something fun full time. Sorry, boss. Okay, what is going on here? Let's just log this, I guess, and see whether I'm actually only having one pixel or not, or one color rather. Because now it's not even flashing red like it was before. Heavy sigh. Colors all the same. I started streaming a port of Alwa's Awakening to the NES at the beginning of the year, but after realizing how Twitch can be a great place to get stuff done, I started streaming some of my everyday development at work as well. Yeah, I am right there with you just lately. This challenge has been a lot of fun despite, you know, some of the difficulties associated with it. And once I've concluded it, for better or for worse, although it's looking like for worse right now, I will definitely have to rethink like what my relationship to streaming is and whether I want to continue doing it. Because I think the answer to that is yes. I just have to figure out like what amount fits in with my life, basically. Twitch can be a great commitment device, not so easy to walk away when you get frustrated with something. Definitely. On the other hand, it can also prevent you from taking a break when you need one to kind of like clear out your head. So, double-edged sword, like most things. At least it flashed red that time. That's good. It's probably just because I slowed it down enough to be able to see it. Like, I probably should walk away from this for a little bit and just kind of get my head right, but I don't know. I'll give it another 15 minutes or so. I'm hungry, too. It's lunchtime for me. Even though it's 3 in the afternoon. Alright, that's probably enough data. Thank you. Okay, so we are rendering all of the pixels. We should be. I'm so confused as to what is now occurring. Yeah, it can come with distractions as well, for sure. Although, honestly, distractions are often kind of beneficial for me, like having somebody to talk to, just keep me from getting bored. What is going on? Why don't you work? So it looks like I am rendering pixels of various colors to my frame buffer, but then they don't seem like they're getting drawn. So maybe my problem is with my whole NMI executed thing, like maybe I'm not actually rendering all that often. Let's print how often we render, shall we? That would be in here. Quit. There we go. Okay. Two, three, four, five. Oh, there it goes. It exploded. As one expected. Drawing. Okay, yeah, so it is drawing a frame buffer regularly. Which I guess is good, but also, like, What is going on then? I've somehow made things measurably worse by trying to fix them. It do be like that sometimes. I mean, I guess I could back it out, but I feel like most of those changes were correct. Sometimes you gotta break it real good before you can fix it. Definitely the case. Alright, I'm gonna take a couple seconds of data with this. Is there anywhere else that I could conceivably be writing to the frame buffer? I don't think so. We write to it here. And we get an immutable view of it here. But we don't write to it, so I don't think we do in here either, right? We get frame buffer just to render it. Right, so like, I don't understand why this is all the same when the colors are obviously different. I'm very perplexed. I mean, I am drawing the darn thing. I'm rendering it. I'm writing it into the frame buffer. It has a color. The colors are different, right? This one is all red. Or no, this one is all green. And then this one is red and blue, so like a purplish color. But all I get is a gray rectangle. And these appear to be in order, right? It doesn't seem like it's jumping around in terms of what pixel it's drawing at. Is the general drawing mechanism working? No, I don't think so. Have you tried just drawing a green square or something? Oh, you mean like the rendery thingy? Yeah, I did a while back. I haven't in a while. What format is it? RGB24. It's RGBA or ARGB, one of those two. RGBA, or it's supposed to be. Which is interesting, actually, because it doesn't necessarily end with 0 in the way that one would expect that it would. NTSC to RGB. Yeah, maybe the alpha is set wrong, and that's why it's not working the way that one would expect it to. So, So this is the NTSC lookup. Pass in NTSC byte, which is like the address. Or no, it's not the address. It's what we read out of the palette. NTSC byte plus I as U size as U32. So what we end up with yeah, 4464, 440064. And I push 4 bytes per pixel. Uh-huh. $68. And 100. Right, so this is the lookup that we're getting. It is a bit odd. It doesn't really make sense. So if I is 0, you left shift it by 24, which means that the 68 should end up at the top, which it does. And then if I is 1, you left shift it by 16, which means that the 0 should end up in the middle, which it does. And then when I is 2, you left shift it by 8, which means that the 100 should end up at the bottom, which it does. But then what happened to the 0? So that doesn't really make sense. Because it should be left shifted by 25. Yeah, I mean, okay, so that seems correct. But if we move the panic to here, that's weird. Assert pixel color and 0xFF is equal to 0. We'll get rid of this. Okay. Well, that doesn't make sense. I need to multiply this by 4. Hey, that looks a lot more right. I mean, it's obviously still very wrong, but it looks a lot better. Whoa, I exploded it somehow. Oh, yeah. Forgot we had that panic in there because you don't believe that the thing is supposed to change. let's just take that panic out for a moment and see what happens. I'm slowly getting somewhere. You're correct. Emphasis on slowly and somewhere. No, I'm kidding. I'm feeling pretty good about the progress that I've made. Even if I don't, like I said before a couple of times, even if I don't finish it, whatever, it's fine. See, that looks like a demo to me. I don't know about you. I can clearly see Donkey Kong and Mr. Mario and the hammers and junk. I mean, it's perfect. It's great. I see some slopes. Yeah, Donkey Kong Country, a game known for the slopiness of its terrain. Or not Donkey Kong Country. Reflex. Those games are way better. Okay, well. Bacon pancakes. Making bacon pancakes. Alright, let's restore the panic. Draw the thing. It does look like I have my TV set to the wrong channel. And functionally, that's what this is. Alright, so this is what we draw. Obviously, it is wrong. All of the tiles are the same, which I suspect is not supposed to be true. So when we do fetch NT, right, we should be getting different things each time. Check if the chur ROM is correctly populated. I could do that. Seems like it ought to just work, huh? Where would that be? That'd be in the NROM mapper. ROM.chur-ROM, right? So we take in the NES ROM, which comes in from here, and we just get the chur-ROM, and we get the chur-ROM based on contents pointer to pointer plus header dot chur-ROM size, prog-ROM size, juvec plus equal header. I mean, that seems right to me. It could be wrong, but let me look at the INS format again. Gotta close all these tabs and start over, I think. Declare tab bankruptcy. INS. Right, so the header is 16 bytes, which is what I'm reading and skipping over. And then prog-ROM data should be 16384 times whatever. Where is the INS header part? There it is. So chur-ROM size bytes is 8 kilobytes. Prog-ROM size bytes is... Oh, hey, would you look at that? I don't think it'll matter. They're probably the same. Nope, didn't matter. Good old copy-paste error. Yep. Doesn't seem to have helped, though. Still gives me weird squiggly lines. Don't think I did anything else wrong. I'm only calling per ROM size bytes anyway, because the NROM mapper only has one size of chur ROM. Although I guess it is being used indirectly. Like, it doesn't make sense that the name table byte always be the same. So I must be reading the wrong name table byte. But I guess it does occasionally become not 24. So let's... What am I looking at here? Okay. All the name tables are 24. All of them forever and for always are 24. And then it explodes. Last one was 3F. Yeah, that's why it exploded, because I asserted that it would not be 3F anymore. Where the hell does one even start with making an NES emulator, lol? I started with the CPU. So there's a... yeah, why not? I need a break. Let me walk you through it. So start with, you need to load in a ROM, right? And the NES ROMs have this default file format called INES, which is defined here. Well, it's not defined here. It's defined by convention, but it is documented here. So the first thing that you do is you parse this file format so you have like the bytes and stuff. Then you know you want to emulate the CPU. So you take a look at the CPU, and there is basically like a reset vector. That's where the CPU starts. And then all you do is you read the value at that reset vector. You figure out what opcode that is for the CPU, which is this. And then you basically write a representation of the CPU, and you manipulate that representation according to the rules of the opcodes that you load. So then you just do that over and over and over again. And that's how you start. And then to make sure that it works, there are test ROMs. So I used NES Test, which is sort of the well-known one. Then you want to move on to running some games, which is what I'm trying to do now. But unfortunately, this is what happens. So obviously, still have some kinks to work out here. But, you know. Oh, wow. Musyun, thank you for the host. Appreciate that. Welcome, everyone. This is the day 14 of 14 of my NES Emulator Challenge that was issued by a rando on the internet. Hi, Sai. And basically the goal here is to make an NES emulator in less than 2 weeks that will run Super Mario Bros. 3. I'm currently trying to run Donkey Kong and mostly failing. Will you finish in time? At this point, signs point to no, but I'm not going to give up. I'm going to keep working. I'm going to be streaming almost all of today. And if I don't make it, I don't make it. Whatever. I had fun. Also, for anyone who's interested, I plan to do like a retrospective stream tomorrow, which kind of goes through the code, explains the choices that I made and why I made them, and things that I would do differently if I were to do it again, things that I like, so on and so forth. So I'm going to kind of do that tomorrow, whether I finished or not with the challenge. So yeah, stop in for that. It'll probably be around like 1 p.m. Pacific. So adjust to your local time zones as needed if you're interested in that. Implementing MMC1 in itself in a week sounds crazy. People keep saying that. It doesn't look that complicated to me, but I mean, compared to like the PPU. But I mean, I haven't tried to do it yet, so who knows? What was I doing? Right, so I think the addresses are wrong. Right, because we only are looking at a few addresses, it looks like. The scan line counter sucks. What's so bad about it? I mean, I'm already counting scan lines. Okay, so we only make it up to 2B in the name table, and that doesn't seem right because the name table is huge. The way it counts scan lines in hardware depends on sprite fetching, etc. Okay. Well, we'll see if we even get there. It may or may not matter at this point. I have not yet decided whether I want to try to finish this emulator if I don't complete the challenge in time, but signs kind of point to no. I enjoyed doing this, but the NES is not the console that I'm most passionate about. Of course, finish. I mean, we'll see. I'll think about it. Yes, so this is obviously wrong, right? Because we're only going up to address 2B, it looks like, in the name table. And then we're just kind of looping. So that explains why we hit the same, we just draw the same thing over and over again. I don't think we ever go, oh, I guess we do go past 2B a little bit, but not really. So I'm doing something very wrong in terms of calculating what byte to get. Name table base plus tile, which would go up to how many tiles are there? 32, 33, something like that. And then plus scan line divided by 8, because I want to get the right thing. Can you dump the first 200 of the PPU to a file and send it to me? I can compare the chairs. Yeah, I guess. I really don't think that's the problem. I'm pretty sure this is the problem right here. Because the address doesn't make sense. Let me try to figure that out first, and then if it doesn't help, I will do that. So how is this supposed to work? What is the address of the name table byte that you're supposed to fetch? Because this is clearly nonsense. Got like 500. You know, we got like a kilobyte of address, and we're only accessing the first like 30 bytes of it. So what's going wrong here? Name table byte. Is someone going to explain to me how you know what name table byte to fetch? I don't understand. So we're basically are going to want to go back to that page with the 4 windows. Which page? This one? Yeah, I really need to just delete a bunch of these tabs. The top 2000 is the first name table byte ends on in the top left. I don't understand that. I'm sorry. One second. Okay, sure. This one? Right, so 0 to 256 and 240, 0 across. Yeah, this isn't as helpful as I would like it to be, but I think I can figure it out from this, right? So basically we need to figure out what tile we're on. Wait, what is this 256? Because these are pixels, not tiles. Left and right, top to bottom, any field, any table. Yeah, I get that. I do. I'm just... Hang on, let me think about this for a second. So, this is showing... Name tables only select tiles, just comes tiles. Yeah, I get it. I know that. I think the problem that I'm having is that I expect this to be like shaped like the screen, and it just isn't. So the actual math, instead of dividing by 8, what we want to do is base plus tile plus scan line divided by 8, whoops, times tiles per scan line, which is 32 or 33, I forget. 32, right? So I think that's what I need. That drawing is dumb. I don't know why they have pixel numbers. I guess they don't, actually. They have like some other totally different thing. It's just all very bad documentation, I have found. Or at least it just doesn't match my brain, which is completely possible. Whoa! Nice explosion, friendo. I forgot I had that insert in. One more time. One more again. Hey, that's recognizable. It says Donkey Kong. So let's turn off that other panic. The Lila doesn't believe in changing screens panic. And then we'll see what the changes are that happen. Thank you, everyone. The kitty cat, welcome. I have not seen you before, I don't think. See, it is the demo, probably. It looked like the demo for like a second, though. Okay, yeah, see? Some stuff is happening. Time to compare chur now. I don't think it's the chur, man. It is scrolling, or appearing to scroll. It's refreshing to see someone else having to debug code. Way too much online is rehearsed, written fast, and bug-free. I'm glad that you're enjoying that, because I am constantly anxious that it's a terrible viewing experience to watch me just slam my head against stuff for an hour. Is your width/height correctly represented by your frame buffer? Yes. I'm going to replace that panic, with a loop, so that we can just kind of observe the state of things for a minute when we get there. So this looks slightly offset, and obviously the tiles are wrong. What the heck was that? Okay, so now we're fetching the right name table bytes, or at least better name table bytes. Possibly not exactly the correct ones, but who knows. Fetch NT. I've been lurking since the stream before your cat destroyed the wired mouse. Well, thank you for your continued viewership. I appreciate that. Okay, so let's look at the log. Okay, this still not sure is correct. 0 to 2b, 0 to 2b, 0 to 2b. I need to be logging the scan line numbers because otherwise this doesn't make any sense to me. Oops. I'm so hungry, but I'm finally making progress. I don't want to stop. But I need food. Okay, delete you. This. Okay, scan line 8. Right, so we should be only going up to 2B, up to scan line 8. And that is correct, which is good. Then, for some reason, we start from 20, which does not seem like what we should be starting from. Seems like we should be starting from 2C. Don't you think? How far is 2B? 2B is 43. Oh, we make a jump. That's why. It's because 20 and then 28, 29, 2A, 2B are the dummy name table fetches. And if we look at our thingamajig that tells us how stuff works, I really do need to close a lot of this junk. Here we go. Right, so there's an unused tile fetch here. And then there's first 2 tiles on next scan line, and then unused NT fetches. So we're not doing first 2 tiles on next scan line like we should be, certainly. Because we stop at 20, right, which is the unused one. Because that's tile 32. This is tile 33, which is unused, which is fine. We can do that. But then we should fetch 20 and 21, and then whatever garbage after that, I think. So, God, I'm so hungry. I really need to stop. If we're on tile 42, what's going on here? Otherwise, we fetch the AT. And then fetch NT. I think we only push from increment horizontal if we're on the correct ones, right? So if tile is 32, delay through H blank. Then we push this with tile 40, which is not really true. Right, so we delay through H blank. Which is supposed to be like tile 1 on the next scan line. I don't think I'm going to be able to focus if I don't go get some lunch. So I'm probably going to stop. Let me just look at this output from this test, and then I will go and get some food and come right back. Be gone for like, I don't know, an hour? Probably less. Have a good one. Yeah, thanks, Infinite Nest Lives. I really appreciate you stopping by, telling me about all your stuff that you're working on. It's very cool. Have a good day. Good rest of your day. All right, yeah, I'm going to take off. I'll be back in like an hour. Thanks, everyone. I really appreciate you stopping by.